I was an operations manager at a grocery distribution center supplying 186 stores. At 4:40, the main conveyor controller failed with 9 hours of chilled inventory waiting and no replacement board available until the following day. I had 90 minutes before loading began to choose between stopping the shift or using an untested manual cross-dock path. I considered waiting for engineering, diverting all volume to another site, or opening 2 manual lanes for only the highest-risk chilled routes. I checked fire lanes, manual handling limits, scanner coverage, and the previous peak rate. A 20-minute trial showed one lane could safely process 410 cases an hour with 2 additional quality checks. I opened 2 segregated lanes, capped each at 380 cases an hour, assigned a safety marshal, required scan reconciliation every pallet, and kept ambient volume stopped until engineering restored the controller. The transport lead wanted all routes released manually. I declined because the added congestion would remove our safety margin and focus the risk on 27 chilled departures. When misscans reached 1.4% in the first half hour, I paused one lane, changed the label position, and restarted only after a 50-case zero-defect check. I wrote the decision, assumptions, owners, and stop conditions on a 1-page control plan so the next shift could challenge the logic rather than rely on verbal context. I used both a leading indicator and a customer outcome measure that prevented a short-term productivity improvement from hiding quality, safety, or backlog age. During implementation, I stayed at the operating point for the first cycle, asked frontline employees what the mechanism missed, and changed only one variable at a time. I assigned named owners for each checkpoint and made escalation thresholds visible in the shift huddle, which reduced ambiguity when I was not physically present. After stabilization, I compared the result with the original baseline, checked for cost or defect displacement, and documented the mechanism for the other shifts. Before committing, I asked a supervisor who disagreed with me to identify the weakest assumption, then converted that concern into a measurable checkpoint rather than relying on consensus. I separated mandatory controls from preferences, which let the team move quickly without weakening the safety, quality, or customer promise that the operation existed to protect. For each alternative, I estimated the likely customer impact, labor requirement, operational reversibility, and worst credible failure, and I explained why my chosen path offered the best balance. I briefed affected teams before launch, checked understanding through questions rather than attendance, and made the escalation route clear to people working outside my shift. I also protected normal operations by defining which work would pause, which work would continue, and who could authorize expansion beyond the initial controlled scope. At every review point, I compared actual performance with the assumption that justified the decision. When they diverged, I changed the plan rather than defending the original recommendation. I made the cost of the choice visible as well as the benefit, because hiding overtime, rework, or displaced backlog would have made the result look stronger but less useful. Once the immediate issue was resolved, I held a short review with frontline representatives and partner teams, captured what failed in the original mechanism, and assigned permanent actions. The follow-up remained on my weekly operating review until the control had an owner, an auditable measure, and enough stable data to show the improvement was sustained. That discipline helped distinguish correlation from causation. I looked for the expected change at the affected process step before crediting the intervention for the overall outcome. All chilled routes left within 22 minutes of schedule, no cold chain or safety event occurred, and 96% of ambient orders departed that day. I would now keep a pre-approved manual routing drill rather than design it during an incident. I also documented the operating assumptions, named the owner for each follow-up action, and set a clear review date so that temporary controls could not quietly become permanent. Before closing the action, I sampled performance across different shifts and demand conditions, so the result did not depend on one unusually experienced team or a quiet operating window. Speed is responsible when the risk is bounded, the stop conditions are explicit, and the smallest safe scope is chosen first.